Hello everyone, thank you for watching this video. My name is Danny Mejia, and I'm going to introduce our group project for our embedded systems class. We decided to use the Xilinx board in an innovative way uh, to create a water level indicator. Now, the task assigned to us was to use this FPGA board um, to sort of create some type of innovation. And what we thought of after research is creating a water level indicator. Now, there's many different changes you can add to this project. Um, and the reason we wanted to go ahead and pursue this was because in many developing countries, um, lack of fresh water is, it's a reality, and they use tanks to sort of hold the water, and and when these tanks are getting full and there's a spillage of water, I mean, it's vital for them to not waste any fresh water. So in general, the materials we used for this project was the Xilinx board, the FPGA board, 8 transistors, 8 resistors, 8 LEDs, some wire, and a mock tank that we used, sort of a Tupperware container. So what we did is we used this microcontroller to reduce the amount of water waste. Now, this project can also be applied to, not just water tanks, but swimming pools, in the manufacturing industry, in brewing, anything that really encases volume. And what we also did with this project is we included the rate at which the tanks either filled up. Now, again, our objective was to place these transistors, and when the water reached that height, it would trigger the code through the FPGA board and display the information on the little built-in LCD. This information, I'm going to go ahead and transfer it over to Mariana, who's going to further explain the justifications for our project.
Hello, my name is Mariana Bertocci. Today I'm going to explain why and where we can use this product. Where? In water tanks, boilers, and pools. By research, we found that in countries like Mexico, Uruguay, and Honduras, people still using water tanks or tinacos. As you can see in the picture, these tanks fill up from city water, but don't use water sensors, which is a problem because it is really hard to know when they are full or empty. For this project, we built 8 sensors and placed them in tanks. These sensors prove the tank's different depth, and the LCD on the board will display the level of the water in the tank.
Hello everybody, my name is Patrick Munoz and I'm going to be giving you a brief explanation of the code we wrote for our project. First, we enter an initialization stage where we declare variables for each of our sensors and assign them a value depending on their position on the water tank. Then we move on to a while loop that has a one condition, so this while loop runs continuously and checks for interrupts. When an interrupt occurs, we call our interrupt handler that checks the current sensor value and compares it with the old one. If there has been a change, then we call our function insert rate and average, otherwise we go back to the while loop. In our function insert_rate_and_average, we calculate the average rate based on the current sensor value and the time for the tank that it took to get to this value. We then use this average rate to determine if the tank is being filled or if it's being emptied, and we try to predict how long will it take for the tank to be completely full or completely empty. Then the process is repeated all over again.
Hello everyone, my name is George Aguilar, and I'll be adding some additional information to what Patrick Mooney just spoke about. First of all, I'd like to go into additional system features. The system features that I'll be discussing with you include the 8 sensors measured on the J6 Xilinx extension header. What we did in essence was converted the user constraint system file inside of the Xilinx EDK so that instead of using the dip switches that were discussed in lab 4, we're going to be using 8 of the pins that are located on the J6 Xilinx extension header. Additional information about this can be found on the Xilinx website. Um, as far as the user constraint file is concerned, all we had to do was make sure that we changed the pin assignments to pins such as the H33 so that we can create the sensor input. An additional feature is that the sensor input is actually just one input to the board that is 8 bits wide. Each bit represents one of the 8 sensors. And so we can say that the first sensor value, and just as an example, is 10 in hex. The next one, in essence, would be C0 hex. And that's because of the nature of the sensor input. The first sensor starts at the most significant bit, and then the next sensor is the next significant, and so it goes up 2 hex values on every increment of the sensor. And when you're thinking about how the water level rises, each previous sensor needs to be activated before the next sensor is activated. Also, the system stores 10 rates to create an average rate, which can be found in the insert average and rate function that Patrick mentioned. We decided on 10 rates. We felt that that was a good number to establish a good rate. And then finally, the average rate that is calculated from those 10 rates that are stored in an array in the program is used to calculate the time to fill or empty. As you saw in his video, it said 0M or 0S, meaning minutes and seconds. And so we use that average rate to calculate that time that it shows. And whether the average rate is positive or negative determines if it's filling or emptying the tank. On to future working conclusions. Um, Obviously, the system could have been improved upon. At least I feel so. I think the team feels so also. One of the things that we researched was improved sensors. Instead of using 8 discrete transitive sensors, we could have used one single conductive sensor. And the good thing about the capacitive sensor is that it has an analog signal. And so as the water level rises, the value changes on the capacitive sensor and gives a more accurate level. As you can see in the picture that is depicted in the PowerPoint, the signal changes as the water level rises, and that can be processed into how full or how empty the tank is, and ultimately giving us a more improved rate average to calculate off of. So that's the second part that could have been improved on future work, was better predictive capabilities, maybe a better rate calculation algorithm. We're just using something very simple where whenever a new sensor is activated or one is deactivated, um, the rate calculation algorithm calculates the rate and then the average off of the 10 values. The inherent problem with that is, let's say the tank is filling all 8 sensors and the array is full of positive values. If it starts decreasing, we only have 8 discrete sensors. For a while, it'll be confusing because even though you're emptying, your rate says that you're still filling, and it'll predict off of filling. Another part of future work that we thought of was that the user interface could have been given additional functionality, such as a reset button or display options. to help reset the rate when they notice it's emptying or filling, or even just creating the reset functionality so that if you ever go from filling or emptying, they could be, excuse me, it'd be reset. So finally, I'd just like to conclude with that the project was successful in creating a prototype. I know that in the video we used the board itself and we didn't actually show a water, we just showed the water tank with the levels marked. I like to say that we did test that. Um, the sensor does work in water, it's just that we didn't want to do that for the demonstration, it would have taken too long and the lab would have gotten kind of a little bit messy with the water tank and using water inside the lab with electricity. So there's probably safer and better ways to do it, but at least we were able to prove our point. The team was able to overcome many programming bugs and challenges because we were working inside of an embedded system. We also experienced some hardware issues when we were coming up with the sensors themselves, and we also were very time constrained. So I hope you all enjoyed the presentation and have a good night.